All right, let's do 8.5, which is conditional probabilities. On the review, problem number 2, okay? It's actually not difficult. The thing is, I never gave you that specific formula for that specific type of probability. So I wouldn't expect something like that on the exam just because I never gave you that exact formula. But if I give you the formula, you'll see that it's actually really easy to do. And I'll do it with you just so you can see, what the formula is. But the main thing that you need to remember from 8.5 is that if you're trying to talk about conditional probability, the probability of A given B is equal to the probability of A, okay? I'm just, sorry. Yeah, probability of A and B over the probability of B, right? The second one always goes below. Okay, that's just by definition. And you can manipulate this to be the probability of A and B is equal to the probability of B times the probability of A given that B has happened. So personally, I prefer to write it this way, but I noticed that our textbook prefers to write it the other way. They just provide it A given B times B. Now, the reason I like to write it this way because it makes sense logically. Event B happens, and then A happens afterwards once B has already happened. Like that's how I think about it logically. But the textbook writes it the other way, and it doesn't matter. It's the same answer. Now, the alternative, or if you reverse it, that does give you something different, where the top is still the same, but now the bottom is A, right? And this means the probability of A and B is equal to the probability of A times the probability of B given A. So if you ever need to construct the AND one, then you just start, I would start with this, like start with one of these, because this is easier to memorize, and then multiply it over to manipulate it, okay? So those are the main ones that you have for conditional, okay? So let's just do problem number 1 from the review so we can practice that, okay? But any questions so far? So suppose that the probability of A and B is 0.4 and the probability of B is 0.9. Find the probability of A given B. Well, by definition, the probability of A given B is equal to the probability of A and B divided by the probability of B, because the second one always goes on the bottom. So then this is 0.4 divided by 0.9, which is 0.36. Right? The first one is supposed to be super simple, right? But let's do one that's a little more complicated, specifically number 4, because I had a few students ask me a question on this one, so I wanted to do this one together. Okay, so number 4. So 2 dice that are distinguishable are rolled, one red and one green. Let A represent the event that the red die is 2 or 4. So A equals red 2 or 4. Let B represent the sum is equal to 6. Find the conditional probability B given A and express your your answer in the fraction. Okay. So they're saying the probability of B given A, which is equal to the probability of sum of 6 given red 2 or 4. So what this is equal to is the probability of sum of 6 and red 2 or 4 divided by the probability of a red 2 or 4. Okay, that's what they're asking for. So first, let's find the probability of A. So this is B, this is A, this is A and B, and this is A. So my first question, How many ways can you roll 2 dice that are distinguishable? How many ways can you roll it? We know this one, like we've done this one so many times now. 36, right? There are 36 ways that we can roll 2 dice that are different. Now let me ask you a question. How many red 2s are there? I can do 2, 1, 2, 2, 2, 3, all the way to 2, 6, where that 2 is a red, right? Does that make sense? Does everyone see that? The 2 is red in all of these. Red, 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 red. So there's 6 of them. And then what's the other option that I have? 4. Does everyone see it's 4? So I can do 4, 1, 4, 2, 4, 3, 4, 6. And yes, 4, 2, and 2, 4 are different. So how many do I have? I have 6, I have 6, so I have 12, which is 1/3. But you can just leave it as 12 over 6. Now, okay. Sorry, I have to actually do this because I need to show that number. So now my question is, what is the probability of A and B where it's both of them? Well, this is red, this is red, this is red. So if I look, 2 plus 4 is 6, and 4 plus 2 is 6, right? Those are the only 2 that add up to 6, where there's a 2 and a 4 that's red, okay? Because the other one is blue. We're going to pretend all the second ones are blue. I think that's the other color we use, right? Oh, sorry, green, not blue. Not that it actually matters. It can't be red. Like that. So that's going to be 2 out of 36 because there's a total of 36 of them, and it's 2 out of 36, right? Does that make sense? Are there any questions on that? I'll make sure. And so then this is going to be equal to 2 out of 36 divided by 12 out of 36. And then the 36 actually cancel each other out, or you can just plug into your calculator and you get 2 over 12, which is 1/6, and you get the answer. Now, are there more than one way of doing this? Absolutely. You can think of it differently, but that's just kind of the way I think about it. Okay. Are there any questions on that? Want to make sure. The other thing that you have to do from 8.5 is the tree, right? So you want to be able to do a tree. But does anyone need more time on this slide? I just want to make sure before I move on. I'll give you a quick second to ask me any other questions. All right, no one said anything. So the next thing is the tree. So tree diagram. Right. So again, there's so many ways of defining the tree diagram. Everyone kind of has their own personal preference. I've shown you mine. I'm just trying to see what they did here. So you can do it this way. So me, I like to do AB, but some people like to do BA. So like if you do A, this would be not A. You do B, this is not B. You do B, this is not B. So this right here is the probability of A. This right here is the probability of A not. This right here is the probability of B given A. This right here is the probability of B not given A. This right here is the probability of B given A not. This right here is the probability of B not given A not. And we learned that moving along the tree is multiplying, and then moving up and down is addition. Yes, we do have Bayes' theorem. You just have to remember the formula that we talked about in class on, what day was that? Monday? Wednesday? Yeah, Wednesday. It's just the one formula. We'll talk about that next. So the probability of A and B, the probability of A and not B, the probability of A not and B, probability of A not and B not. And so this is equal to the probability of A times the probability of B given A, probability of A times the probability of B given, sorry, not B given A. So if you're going along the tree, you're multiplying like that. Okay, so this is multiplication. And then if you're going up and down, you're adding like that. And so this probability of not A, that's the probability of B given not A. And this probability of, like, I'm going to tell you right now, don't focus like, oh my God, I need to memorize this entire table. You really don't. Okay? It's just kind of like a flow to it. And then I think, yeah. And then you can do it the other way around. You can change A and B and then everything just flips around. So let's do the one question from the homework. And then I think that covers 8.5. And then I'll show you how to do number 2 really quickly because that one was kind of a weird problem. But it's not that it was just because I just never gave you that specific formula, unfortunately. That's my fault. All right. Anyone need more time on this table? Okay. So hopefully we don't run into any issues with these. Even conditional is probably like one of my weakest areas personally. So like it's still something that I get it. Like I get it. It's just like not the strongest thing on that. So there is a 30% chance of rain today and an 80% chance of rain tomorrow. Assume that the events are independent. That's good. And that if the rain and if the event, if it rains tomorrow, what is the probability that there'll be no rain today or tomorrow? Okay. So when you have independence, the probability of A given B is equal to the probability of A, and the probability of B given A is just the probability of B. Okay. So in this case, you want to calculate the probability of no rain today or tomorrow. So or means addition. So let's make our tree. And so we're going to do today. Sorry. Rain today. No rain today. And then from there, rain tomorrow. No rain tomorrow. And then rain tomorrow. No rain tomorrow. Okay, does everyone see that? So what is the probability of raining today? 30%, because they tell me right there. And each of the branches, like this, like pair, they have to add up to 1. So then this has to be 70% of no chance of rain today. And then look at the tree. This right here is the probability of B given A. However, I said independent, which means the probability of B given A is just the probability of B. So rain tomorrow is 80%, which means this has to be 20%. And then this is 80%, and this has to be 20%. That independence does save you quite a bit of a headache, okay? So be aware of that. That independence does make a difference. Because if it's not independent, then a little trickier, unfortunately. And so the probability of no rain today or tomorrow, I'd say tomorrow, is going to be equal to so it's going to be no rain today right? So remember, or is kind of tricky because it only has to satisfy one of them. So it can rain not today. Sorry, want to make sure I say this correctly. And just double checking that I'm recording. So sure. Again, sometimes these are tricky. So we want it to rain. There'll be no rain today or tomorrow. So we want no rain today. Why do I keep erasing? Sorry. We'll do this one right there. Although I think their answer is 0.14, which to me, I'm just thinking real quick. Because if it doesn't rain today or tomorrow, and tomorrow, then that's 0.7 times 0.20, which is 0.14. However, I think based off of their answer, because their answer is 0.14, but if you think about it, I feel like it should be an and statement. Because then you would want to add this one to it because it's not raining tomorrow. And then you would want to add this one to it because it's not raining today. So there's three scenarios that satisfy the or statement. So I think it should have been an and statement, unless I'm missing something, which no, I don't. But then their answer wouldn't make sense. So just to be safe, I'm going to change this to an and because if you change it to an and, then it's correct because you're just moving along the branch and you multiply and you get 0.14. So just change it to an and now it's perfectly fine. It's that because or is a little tricky. It can be one or the other or both. And so that's where you got to be a little careful. So just change to an and now the answer is 0.14 instead. I'm actually going to probably email the coordinator about that just to verify because, like I said, I don't think the answer really makes sense that way. Okay, but that pretty much wraps up 8.5, just being able to fill out a tree. Remember, these two numbers have to add up to 1. Like along the branches, they always have to add up to 1. Okay, and if you do, then you're on the right track because if they don't, then it's definitely no good. Now, let's talk about that one problem number 2. Like I said, this don't expect just because, again, I didn't really go over this formula specifically, but in case you were curious on how we got the answer, I'll do it very quickly. So there's a specific formula in conditional. Actually, I think it's from Bayes' theorem. It's from Bayes, and that's what's weird. Is it shouldn't even be in this section. It should be in Bayes' theorem. So the probability of A is equal to the probability of A given B times the probability of B plus the probability of A given not B times the probability of not B. Okay, like I said, I never gave you this theorem, so don't memorize it. I'm just showing you how to do this. Well, I know what this is, 0.7. I know what this is, 0.4. I know what this is, 0.5. And then the probability of B complement is 1 minus probability of B. So that's just going to be 0.6. And then that's the answer. Like, that's it. It's honestly not that bad. It's just, again, I didn't tell you this formula because it's not even in the textbook in those like notes. So it's just kind of a one-off right there. Okay. And that's how you do it. Any questions on that? Just in general. But again, don't need to memorize that formula or anything like that. All right, now let's just talk about Bayes' theorem, our final topic, and then I'll do that one extra problem that you asked about. Bayes' theorem. So we'll just do the example. So this will be number 6. For question number 7 and 8, definitely number 8. Sorry, questions 8 and 9. Like, so definitely not number 9. We're not going to do 3 of them. Like, I'm not going to make you do 3 on an exam. And then question number 8, ignore that one. The way that it's worded is so confusing. Don't worry about that, because it's just like it's the way they worded it was just very confusing. So you can ignore that one. But number 7 is one that's a little bit more interesting. So the theorem is the probability of A given B. Sorry, wrong way. Actually, no, it'll work this way. B given A is equal. So what you do is you flip it, and then you multiply it by the second letter, so B. Okay, and then on the bottom you just copy and paste it over. So copy and paste down, and then you're going to add it times the first letter doesn't change, but then you do the complement of B for the other two. Okay, and that's the formula. And you just have to memorize that. And so the question number 6 on the review states, okay, go back to question number 2 that we just did and find B of A. So what we want to do is find the probability of B given A. And so I'm going to copy those numbers down over here so that we can have them. So this is equal to probability of A given B, 0.7 times the probability of B, which is 0.4 over 0.7 and 0.4 plus 0.5 times 0.6. And if you do that correctly, your answer will be 0.483. And that's really all you have to be able to do with the formula. It's just, know that formula and calculate. And just be able to apply that to some potential word problems, right? And then I might just, should we do the one? Let's see, do we have time? I think we do. Let me just look real quick. No, that's not gonna be. I mean, no, that's a different type of problem. So yeah, number 7. Now, yeah. Any questions though? I just want to verify because I'm gonna do that one question that I was asked about earlier. All right, so this is the end of 8.6. Like I said, just be able to do the basic base theorems, like the first 4 homework problems. Like if you could do those, you're set. Like that's really what I was looking for. But what question was it from the review? 37?
38, please.
38, yeah. Find the median. So yeah, we'll do that one real quick. And then we're done. Almost 3 hours. Not too bad. I had longer ones than this. Okay, so to find the median, you just take the integral from 0, or wherever the bound begins, to m, so wherever the starting bound is, m of the function. So it was 3x squared dx, and then that's going to be equal to 1/2. Okay, so then the integral is 3x cubed over 3 from 0 to m, which is equal to m cubed minus 0 cubed equals 1/2. So m cubed is equal to 1/2. So then the cube root of both sides. So m is equal to the cube root of 1/2, which whatever number that is. 0.793. 0.5 to the 1/3. Yep, 0.793. That's it. It's not a mu, it's an m. I know it looks like a mu, but it's m. That's it. Any questions on that? All right. Well, for those of you who stuck around to the end, I appreciate it. I'm gonna stop recording.